Okay, final question here. We have a plane, PQR, and it's parallel to the base of the pyramid and bisects the altitude, so that's the height. So like from here to here, this plane bisects it, okay? So you can think of altitude as the height, and that statement, I know it's not drawn really well, but maybe draw like this where it like connects to like the back of it, I don't know. But anyway, the fact that it says it bisects the altitude tells us that the height of the smaller pyramid, which would be like this one, right here, is going to have half the height of this larger pyramid, all right, because the heights are bisected, so like it's the midpoint. Find the ratios, all right, so by knowing that the height of the smaller pyramid is half the height of the larger pyramid, and we also know that they're similar because these are parallel planes, so like they're going to be the same shape, all the angles are going to be the same. Alright, we know that the scale factor is going to be 1 to 2 or 2 to 1 depending on how it's asked. So the perimeter of PQR to the perimeter of ABC, alright, we know that they're similar because they have the same angles, those triangles, and we're going from the smaller triangle to the bigger triangle, and perimeter is in length, which is measured in units. So we're not going to square or cube our scale factor, but we are going to write it like this, 2 to 1, because it's going from the smaller to the bigger one. Okay, then it's asking about lateral area. Now, surface area, lateral area, if the lateral area, so if you have two similar pyramids, their lateral areas are going to have the same scale factor as the surface areas. So as long as you're comparing like the same areas, you can still use the rule that the ratio of areas is equal to the scale factor squared. So the top part of the pyramid to the whole pyramid. So again, we're going from a smaller part, the top part of the pyramid, so like VPQR, to the whole pyramid, VABC. All right, those triangles. So we're just going to still write it as a number bigger than 1, but we're going to square it now. So the scale factor is going to be 4, or 4 to 1. Okay? The lateral area of the top part of the pyramid to the lateral area of the bottom part of the pyramid. Alright, well this is interesting. If we take our, so we just said that this top part in B has a ratio of 1 to 4 to the entire pyramid. So if you consider this entire pyramid is made up of 4 of these, okay, 4 of these orange parts, the top part, then that means you could fit 3 of them on the bottom part of the pyramid. Alright, so again, B tells us that the bottom part of the pyramid is made up of 3 top parts of the pyramid because the whole pyramid is made up of 4 top parts of the pyramid. So we're going to write that as the lateral area of the top part of the pyramid to the lateral area of the bottom part of the pyramid is going to be 1 to 3. Then the volume of the top part of the pyramid to the volume of the bottom part of the pyramid. Alright, well first, if we know that the scale factor of the top part of the pyramid to the whole pyramid is 1 to 2, then if we cube that, we get that the ratio of the volume of the top part of the pyramid, VPQR, to the whole pyramid is going to be 1 to 8. Alright, so that means that this whole pyramid is made up of 8 of these. You could fit 8 of those top parts that I just highlighted in blue. That means that the rest of the pyramid would make up 7 of those. So our answer for this, when it asks us the volume of the top part of the pyramid to the bottom part of the pyramid, we're going to go with 1 to 7 because now we're not comparing it to the whole thing, we're comparing the top part to the bottom part.